Hey buddy, so let's talk about the multi-tenant architecture. So we will talk about multi-tenant architecture, how you can implement, a small scale application, and then how can you implement that is enterprise level application, right? Okay, before we start talking, that deeply about the multi-tenant architecture, let's try to understand this word called tenant. So tenant simply means tenant is equal to customer. So when someone says that go and create a multi-tenant architecture, so that means they're asking you to create a software, write a code in a way that the same code can be produced to the multiple customer, right? And when someone says single tenant architecture, that means simply means this software, this product that you have written will only work for one customer, right? Okay, now let's try to understand more simpler language. Okay, imagine you are living in your private villa. You have your own land, you have constructed your own house, you have your own garden, you have to pay for security, right? Everything by yourself, no one is going to contribute there. So that is what the single tenant architecture is. Now multi-tenant, imagine you are living in a building or society where you have a shared garden, you have a security, and in that building you are living in a apartment, right? So the same infrastructure, but you feel that you have your own home. So if it is a security fee, it's a garden maintenance, all those maintenance are shared. That cost is being shared between those people who are living there. So that is what the multi-tenant architecture is, right? So that is a simple layman language. That means right, each customer feels like they have their own isolated villa or isolated system, but internally they share the shared architecture, the shared infrastructure, right? So that is what the multi-tenant architecture is. Okay, now let's go and try to understand from the implementation perspective, how can you implement. Okay, so let's talk from the diagram view now. If you look at this diagram, we are saying this is a single code that is hosted. That single code is used by customer A, which is tenant A, customer B, which is second customer, tenant B, and then third customer C, and that we are calling tenant C, right? So same code has been used by this different customer, right? And that is what in simple language, that is what the multi-tenant architecture is. Now, before we go more deep, let's try to understand what benefit you have received and also the customer, right? So this is cost efficiency. The first benefit is cost efficiency. So you don't have to pay as a customer a lot of money, because you are on a shared resources, right? So definitely the money, the amount, the expenses will be divided as well between the three customers, so that will be less costly. Now easy maintenance, right? Because the resources are shared, so if something goes down or something we have to scale up, that needs to be done at one place, and then all those benefits will be received by all the customer, right? Okay, now the faster onboarding as well. Tomorrow if we have a fourth customer, for us it will be very easy to onboard them, because all the structure, everything is already there. We just have to invest on onboarding the new customer. So onboarding will also be easy when we have to onboard a new customer, right? Okay, now let's go further. So over here for sure there will be a single app code. Along with simple app code, you can have your just one database, right? Remember, these implementations are for the small scale application, not for the enterprise level application, right? When you're going for the multi-tenant architecture, so you have one code and one database deployed for all the customer, right? So same database has been used by customer A, customer B, and customer C. Now let's try to understand. In that database, let's say there is a table called product, right? So what will you do? You will create a table, right, called product, along with a schema name. Let's say you will name let's say customer, the name of the customer is customer A, so you will put a customer name here. You will say customer A underscore the table name product, same customer B underscore product, customer C underscore product. So that means different customer would have their own tables along with their tenant name, their customer name, in the single database, right? And now let's say you wanted to use the database and common table. You don't want to go for, customer A underscore product, customer B underscore product, or customer C underscore product. Instead, you just wanted one table for all the customer, whether, it is customer A, customer B, customer C, customer D. You just want one table, that is product, right? Now over here, how will you implement, right? So what will you do in the table? You will create your column structure in a way, you will design your table in a way that, you will put one column tenant ID, and in the tenant ID there will be ID of customer A or customer B or customer C, and that is how we will identify, okay, in the product table this row belongs to this table, this row belongs to this tenant, and the other row belongs to that tenant, right? That is how you can identify. So you can implement using the same database, either with a schema, different schema name and then table name, or the common table along with a tenant ID. These are the two ways you can implement when you wanted to go with a single approach, single database. Now coming to the other approach, let's go further. So over here you have a single app code, but you wanted to have their own database. You don't wanted to provide one database, common database to each customer, because the size of data is quite heavy, right? So in that case, what will you do? The single app code still be there, right? Single app code has been shared by customer A, customer B, and customer C. That means 3 different tenants, and each tenant will have their own database. If you look at this diagram, right, tenant A have their own database, tenant B have their own database, and tenant C have their own database. So this is one way you can implement when you have large scale of data, and if you go with just one database or one table, that could be quite heavy, and when it comes to the end user, the performance will be quite slow. They may not like that application, that why whenever they click on one button, it is taking like say 30 seconds or 1 minute just to get the data, right? So they may not be interested. So in those cases, you can go with their dedicated database, but again the code base can still be same. There is one more way that you can implement. So when you go from multi-tenant architecture, in there you have your own, every customer will have their own deployment model, right? They have their own database and they have their own code as well. The code will still be same, right? When you have written the code, the logic is still going to be same, but that logic needs to be deployed on different servers, right? And each dedicated, but again that is not a multi-tenant architecture. Multi-tenant architecture simply means that same code, same database, or maybe a different database, but same code is being shared by, and same infrastructure as well is being shared by the customers. But if you go to very large, where you produce a product, you make your changes, you make your bug fixes, you make your upgrade at one place, and then you share the same code to different customer, and different customer have their own set of deployments, right? Own set of machines. But that again is some part of multi-tenant architecture, but not exactly multi-tenant architecture, right? Okay, now how it works in the the UI and API world. In multi-tenant architecture, when UI make a request to the API, they will receive a token, right? The first request will be for that, give me authentication token. In that authentication token, you will have a column called tenant ID. You will pick that tenant ID, then against that tenant ID, you will again make your request from the UI side to give me a data for these tenants, for this tenant only, right? Okay. Now this was straightforward from UI to API. Coming to here, so when you go for a multi-tenant architecture, the one way you can give dedicated domain, right? And in a dedicated domain, you will produce each customer, their specific domain, www.customer1.com. It could be any name. For customer 2, it will customer2.com. So you know that, right? It will be dedicated domain. Or you can go with a shared domain. So this will save a lot of cost if you go with a shared domain. So it is like HTTP. So take example of gmail.com, right? So gmail.com, there are millions of users, million or billion of users, right? So there is just one URL, shared URL, www.gmail.com, and then you have your own IDs, right? You are, let's say I'm Parveen, so let's say Parveen, right? If you are, John, let's say gmail.com and John, right? So that is a shared domain, but that is also a multi-tenant architecture application if you take example of Gmail, right? These are the way you can implement the multi-tenant architecture, right? So you could have single app code and different customer, right? Then one database with different schema and table, or with one table along with a column, a foreign key as a tenant ID, right? And then or there could be other way, when you have a large set of data that can't be handled by one database or one table, then you can go with one single app code, but for each customer you could go with the different databases, right? And then when UI make a request to the API, you will have tenant ID back in the response. So whosoever user is logged in on the API side, it will identify, okay, this user belongs to this tenant, give a tenant ID in the token, then UI will make a further request as per their tenant, right? So they will not get data of any other customer, they will only get data from their customer, and then dedicated domain and shared domain, right? Okay, so I hope you enjoyed this. If you really did, please do subscribe the channel so I can create more videos on these concepts. Okay, that's all for today's video. I will see you in the next video.